The complete system of tree rigging. At the beginning of this series, we talked about control. Not ropes, not gear, not knots. Control. At that point, control probably sounded simple. Lower the piece slowly. Don't break anything. Stay safe. But now, after everything you've learned, control should feel like something much bigger. Because control is no longer just an outcome. It's a system. It's every decision you make before the cut. It's every variable you account for. It's every movement you predict before it happens. You've moved from seeing individual parts to understanding how everything connects. From your very first concept to handling the heaviest wood in the tree, every step is built on the last. And now you can see the full picture. Everything in rigging is the management of energy. At the start of this series, we defined rigging as the controlled movement of wood. Now you understand what that really means. Every piece of wood in a tree holds potential energy. A limb over a roof, a trunk section high on a spar, a top ready to be removed. All of that energy is stored, waiting. The moment you make a cut, you release it. That potential energy becomes kinetic energy. The piece begins to move. It accelerates. It builds momentum. And then, your system has to deal with it. The rope catches. The anchor absorbs. The friction device controls. And whether that happens smoothly or violently depends entirely on your understanding. Let's go back to the beginning. In the first podcast, you learned the basic structure of a rigging system. An anchor, a line, and a control point. At first, that might have seemed straightforward. But think about what that really means in practice. You're removing a limb over a driveway. Your anchor is a union high in the tree. That anchor must withstand not just the weight of the piece, but the force created when it moves. Your line is your connection. It transfers that force from the piece to the system. And your control point, the friction device on the ground, is where that energy is managed. If the anchor is weak, it fails. If the rope is overloaded, it fails. If the control system is misused, the piece drops. That's where things start to change. From thinking about cutting wood to thinking about systems. Then you moved into equipment. And this is where you began to see that not all tools behave the same. A 3-strand rope might feel strong, but under load, it twists. It transfers that twist into the piece. Now your load is rotating. A double braid rope, on the other hand, is stable. It handles dynamic loading better. It gives you more predictable behavior. Now imagine rigging a heavy limb over a greenhouse. If your rope twists and the piece rotates, you've just introduced risk. That's the difference between using equipment and understanding it. You also learned about bend ratio. Running a rope over a small carabiner versus a large arborist block with a proper sheave. In one case, the rope is stressed, weakened, and wearing faster. In the other, it's supported and protected. That's where it starts to come together. From using gear to understanding how gear affects force. Then came knots, and this is where your system became personal. Because now, your hands are directly shaping the outcome. You learned that a bowline creates a stable, fixed loop. You learned that a running bowline allows the rope to cinch down on a limb. Now picture this. You're rigging a horizontal limb. You tie a running bowline near the tip. As the piece is cut, the loop tightens. The limb swings in a controlled arc. Now imagine using the wrong knot. The knot slips. The piece shifts. Now your entire system is unpredictable. You also learn to dress and set your knots. Because a poorly dressed knot doesn't distribute load evenly. It can slip. It can weaken. It can fail. That's where you stop guessing. From tying knots to building reliable connections, then you stepped into real rigging. Basic limb removal. This is where everything started to move. You learned how friction works. In natural crotch rigging, the rope runs over the tree itself. That creates friction at the top. It slows the rope, but it also wears the rope, and it's less predictable. With a false crotch, using an arborist block, the rope runs smoothly, less friction at the top, more control at the ground. Now imagine lowering a limb over a fence. With natural crotch rigging, the rope may grab and release unpredictably. With a block, the movement is smooth, controlled. You also learned about tip tying and butt tying. Tip tying reduces fall distance, more control, less force. Butt tying allows more drop, more efficiency, but also more dynamic load. That's where you begin to think ahead. From understanding concepts to applying them in real scenarios. Then things got more advanced. You learned that where you place your rigging point changes everything. Above the piece, the rope engages quickly. Less fall, less force. Below the piece drops farther, builds more energy, and hits the system harder. Now imagine blocking down a trunk. If you cut a large section with the rigging point below, that piece falls, accelerates, and when it hits the rope, the force can be several times its weight. That's dynamic load. You also learned about redirect rigging, adding a second block to change direction. Now the rope doesn't just go down. It moves across the tree. But every redirect adds force. The anchor at that redirect may experience more load than the original piece. That's where you start to see the system, from controlling movement to predicting force. Then came compound rigging. And this is where everything expanded. You stopped thinking in single lines and started thinking in systems. Instead of one rope carrying all the load, you used a load transfer line to share it. Instead of letting a piece swing freely, you used a control line to guide it. Instead of dropping material straight down, you used a speed line to move it across a space. Now imagine removing limbs over a house. Without a speed line, every piece must be lowered carefully, avoiding swing. With a speed line, you send the piece away from the structure entirely. More equipment, but less risk. That's where your understanding deepens. From simple systems to engineered systems. Then you went deeper. Forces. You learned that the system does not feel weight. It feels movement. A 100-pound piece dropped a few feet can generate far more force than its weight. You learned about potential energy, kinetic energy, elastic energy. You learned how rope stretch absorbs force, how friction dissipates energy, and how fall distance is often the most important variable. Now imagine two identical pieces. One is lowered smoothly. The other is allowed to drop. Same weight, completely different forces. That's where you stop reacting and start predicting. From seeing what happens to understanding why. And finally, you reach top removal and heavy wood. The highest stakes. You're tied into a spar with your lanyard. There are no branches left, no backup. You're above the system, cutting into the trunk itself. You make a bore cut. Establish your hinge. Complete your back cut. The top begins to move. This is where everything you've learned comes together. If the piece is too large, the dynamic load increases. If the hinge fails too early, the piece drops uncontrolled. If friction is not set correctly, the system is shock loaded. If the trunk splits, you risk a barber chair. But when everything is done correctly, the piece moves exactly as planned. Controlled, predictable, safe. That's where you trust the system, because you understand it. From understanding forces to managing them under pressure. So now, step back. Look at everything you've learned. You understand that every piece of wood holds energy, that every cut releases it, that every rope redirects it, that every device absorbs it. You understand that rigging is not about strength. It is about control. Not reacting but predicting. Not guessing but engineering. Because the difference between success and failure is rarely the equipment. It's the understanding behind it. And now you have that understanding. You've built it step by step, through systems, through equipment, through knots, through application, through force, through experience. And now, you don't just perform rigging. You design it. You see the outcome before the cut is made. You understand how the system will behave. You control not just the piece, but the energy behind it. And that is what mastery looks like. Because in the end, you are not just removing wood. You are managing energy, controlling force, and shaping every outcome before it happens. And that is the difference between someone who works in trees and someone who truly understands them. You've been listening to the Arborist Podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.